We are live. There we go. Okay, so today's date, we're going to talk about inverse relations and functions of graphs. Okay? 1/24/2020. Okay? Inverse relations and functions of graphs. Now I use the word relations because not everything, when you do its inverse, turns out to be a function, right? Think about just a y equals 3 becomes an x equals 3, right?
The last graph we did wasn't functioning.
Yeah, it was.
The one we did on here?
Yeah. Oh, maybe the chart might not have been. The graph was.
Yeah.
Yeah, the graph was.
Oh,
It's okay.
okay, I guess. Well,
Let's do it. Okay, what's an inverse of a graph? Okay, so that's where you're going to switch x and y values to become y x values. Okay, so if you have a point A, we go A inverse. So this is our symbol. This is our symbol right here. When you see this, it's not an exponent. It just means inverse. Okay? Yeah, I'm ignoring my phone. Okay, do all functions have inverses? No, they don't. Because sometimes, the easiest example is a y equals 3 equation becomes an x equals 3 equation, and that's not a function, right? So we'd say it does not have an inverse, okay? Well, we can fix it. So, easy. Output, input, those are my x, y's. So find the inverse of this relation. So I'm just going to make my little chart, right? I'm going to redo it. And it's as simple as this. Let's go. Our new input are my new x and my new y. Okay. So the output becomes the input and the input becomes the output. I'll say it again. The output becomes the input and the input becomes the output, right? So we're just going to switch them. So in this case, I'm going to have a -8 for the x and a -2 for the y. -6 for the x and a -1 for the y. -4 for the x and a 0 for the y. And a -2 for the x and a 1. And a 0 and a 2. Okay? How's that? Okay.
Can we just like cross out input x, output
Sure.
y, and just say y?
Yeah, that's fine with me. Yeah. Okay, now, from what I see, this does have an inverse because there's not a single x value here that repeats with a y. So this is an inverse, okay? If I'd done this, okay, and here, let me do it on the board. If I'd done this, it would not have an inverse because 0 can't go to 2 and 0 can't go to 3 at the same time. That make sense? But I didn't. So this definitely has an inverse. It's a function, okay? Okay, now graph both sets of points. Well, I can do that. That's easy. So then if I go, my first one is a point, -2. These are points, right? So I'm going to go -2, -8, 1, 2, 3, 4, 5, 6, 7, 8.
Do we have to graph both of them?
Yeah, I want to show you why. There's a reason why, and you already know the reason, but you haven't discovered it again. -1, -6, 0, -4, 1, -2, and 2, 0. Okay. There's my first one. Let's just call that f of x. Okay. There's my first one. And I'm going to graph my inverse in pink. And it's going to be -8, 1, 2, 3, 4, 5, 6, 7, 8. -2. Am I going too fast? Am I okay? All right. I'm going to graph -6, -1, -4, 0, -2, 1, and 0, 2. Okay. So,
You answered from just figuring out the differences in the...
well, it's the opposite slope. It is the opposite slope because it's got 2 over 1, it's got 1 over 2. So,
And what's not as I'm saying, like, you could find the slope of the thing in, like, just figuring out what the difference is.
yes. Okay, now let's go back to what Raleigh said. You ready? x-intercept of this one becomes the y-intercept of the other graph, or the y-intercept of the function becomes the x-intercept of the original, or vice versa, right? It makes sense, okay? Now, what I want you to see is this. You already know this, but check this out. If I draw in this line right here, and we did this before. This is the line y equals x, right? What we find is that a function and its inverse are reflections over the line y equals x. And we had done that before, but I never called it an inverse, did I? Remember we did that reflection? And I remember how Austin said, well, I just went straight across like that, or went straight across like that, right? And then I showed you another way to do it, and the other way I showed you was we switched x and y's. So we're doing an inverse, which is what we're calling an inverse, okay? Okay, good. So far, so good? Okay. Everybody with me? Inverses are easy, okay? Turn the page. Okay. So, number 2, go ahead and graph this while I sign this. Okay, fun. Homework's in the journal, okay? And I can't remember exactly what page it is, but section 1.3 is the examples and do them all, okay? All right. Okay, so start at -2, up 1 over 2, up 1 over 2, right? Right? Now, here's another way to do its inverse. I know you can see this. Instead of switching xy, 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 let's switch them all at once. Well, the way to switch them all at once is you switch the variables. Because this x represents all the x's, this y represents all the y's. So we're going to switch the variables so that it gets inverse equation. I'm going to rewrite it as x equals 1/2 y minus 2. So I just switched, by switching x and y right here, in a sense, I just switched every single x and every single y, right? Much easier than just going point by point, okay? But if I want to graph this inverse, I should probably solve for y, because then I can graph it, right? Solve for y. So I'm going to solve for y. I'm going to go +2, +2. Yeah, Penelope?
Couldn't you just like plot 2 points and then?
Yes. Yes. I don't want to do it that way. Yes. I think it's faster this way, because eventually I'm going to ask for the equation anyway, right? Yeah, Rally?
Would the 1 over 2, why would that be? The 2 and the 1 be flipped since it stopped?
It will, but wait and see. Yes, it will. Okay, but I haven't fixed it. So let me solve for y, and you're going to be correct after I solve for y. Okay. So let's solve for y. +2, +2. You guys are right. +2, +2. So I have an x plus 2 equals a 1/2 y. Okay. I'm just solving for y. Andrea, I know you're with me, right? There you go. You taking good notes, girl. Okay. So I switched them. Boom. Right. Now I'm going to solve. So solve for y. You guys did this in algebra. +2, +2, right? You can't add x plus 2 because that's an x, right? Please tell me you know that. If you don't, I'm sorry. I'm going to get rid of the 1/2 by multiplying by 2 over 1. Or 2. 2 is easier. So if I multiply both sides by 2 over 1, and multiply this side by 2 over 1, then the 1/2 disappears, and I get y equals a 2x plus 4, right? Now, Rally, to answer your question, because you were correct, that's a 2 over 1.
How can you solve for y if you don't have x? You don't need x.
I'm a little confused.
Well,
I do have x.
Y isn't supposed to be a number, it's a line. So it's like y is
Yeah,
not an exact number, it's a line showing every number
every
that
y
could
value.
be an answer.
Yeah. Okay, so let's graph this, okay? So if I have to graph this, and I'm going to do one more thing. Okay? Now, what's the equation of the inverse? Okay? I'm going to do one more thing. Watch. You see this? Y equals, you see this? Y equals 2x plus 4. You see this? Y equals 2x. I'm going to rewrite as F inverse of x equals 2x plus 4. Same thing. The only thing I did is I made it F inverse because it's the inverse. I just rewrote it with this symbol because that's the inverse, isn't
So
it?
you were just turning it into y.
So I did is change that symbol, the y value to F inverse because this is the inverse, okay? Yeah, really?
What?
Huh?
So when you multiplied everything by 2,
Yeah.
what happened to y, or 1/2 y?
Good. So 2 cancels 2,
Because when you do,
and 1 cancels 1. What are you left with?
Oh, y, okay.
There you go. Yeah, Penelope?
if you went to graph the first, like before you solved it, the x equals 1/2 y. how would
Yeah. I'm going to do that right now. So if you were to just graph it, originally just graph it, right? Here's
So
a
you would
point
flip the
at,
slope?
I did flip the slope, yeah. And that's what Raleigh was saying at the point of 2. In fact, he said 2/1, didn't you? You said that early on. And it, sure enough, up 1/2 becomes up 2/1, right? The y-intercept becomes the x-intercept, or the x-intercept becomes the y-intercept, okay? Now, last but not least, we're almost done. So, example 3, find the inverse. Don't graph, let's just find the inverse. So if I have to find the inverse, I'm going to do this. F of x is y. Capiche?
Yes.
F of x is y,
Yes.
right? I want to get the inverse, so let's switch the x and y's. All of them. So let's make this x and this y, right? So we're going to go, all right, x equals 3y minus 12.
Wouldn't it be 1/3?
You're way ahead of me. Yes. I need to solve for y. Solve for y. So I'm going to go plus 12 plus 12. That is x plus 12 equals 3y. Penelope, we're going to get a 1/3 in just a second because we're going to divide by 3 everything, right? Divide by 3 everything. So, Penelope, that's a 1x, correct? So how about a 1/3 x plus 4 equals y? And I would take that on a test. However, being a mathematician, I'm going to rewrite this as F inverse of x equals a 1/3 x plus 4. And that's my inverse equation. There you have it, okay? Now,